So if you need to know how to figure out the domain and range of a secant function, you've come to the right place. So what we're going to do is take a minute to analyze it. Domain. Domain we like to look at from left to right. Domain is describing the set of inputs or x values that will satisfy a given equation that will be giving us something with a defined answer, will not cause our function to be undefined, right? For example, a square root function. You cannot, if you had y equals the square root of negative x, you cannot put a negative number in the radical in that situation because you can't get a real answer when you try to take the square root of a negative. So negative numbers are not in our domain because we won't be putting them in as an input. We won't be putting them into our equation for x. What about here? We have a lot of random spots where we have these bad numbers, okay? So you are secant, you ask your parents, unit circle and I don't know, triangle, and you're like, hey, can I go hang out with my friends? And they're like, yeah, sure, you could go hang out with your friends, you can hang out with anybody, except I don't want you hanging out with that pi over 2, and I don't want you hanging out with pi over 2 or 3 pi over 2 or 5 pi over 2. I don't want you to hang out with either 7 pi over 2, negative pi over 2, and you're like, what's wrong with the pi over 2 family? Why do you hate them so much? So apparently off limits. You're not allowed to hang out with them. You will be undefined in those situations. So how do I say that x can be anything except those things in a nice, concise way? All right, well, let's look right over here. Domain. This time, I know in another one, I think in maybe it was cotangent or tangent, so a future video, I know I wrote it a different way. I'm trying to write it slightly different each time. I'll try to write it with mostly words for now, just so we can really wrap our minds around, okay? X can be any real number. We're not dealing with any imaginary numbers, okay? X can be any real number except what? I like to pick, I usually just go to this default cycle. I like to pick the first asymptote from the left to start. So that would be for me right here, pi over 2. So except pi over 2, that's one of an infinite number, except, I guess we could write a little bit more to it, except x cannot equal pi over 2. Now, how far apart is pi over 2 from 3 pi over 2? Well, the distance from there to there is 2 pi over 2. The next asymptote would be at 5 pi over 2, which is another 2 pi over 2 away. The next one would be another 2 pi over 2, and another, and the same in the opposite direction going to the left. So in the positive and negative direction. So I can't just say this one, comma, a bunch of them, dot, dot, dot. No. What we're going to do is we're going to write now plus the distance between them, which is, for now, I'm going to use 2 pi over 2. I know it reduces to pi. Keep in mind that this is also 2 quarters. A quarter goes from one tick mark to the next. This is really one tick mark to the next after that. So 2 quarters is a half, right? So 2 quarters apart. 2 pi over 2, but am I only adding it once, twice, 3 times? So we're going to say 2 pi over 2 n, but now we need to define what n is. When I'm trying to use words, not symbols. So x can be any real number except x cannot equal pi over 2 plus 2 pi over 2 n, given that, so this is us describing what n is, given that n is an integer. real numbers and integers are not the same. Real numbers are everything except imaginary numbers. So real numbers include rational numbers like 2/3 that you could write as a fraction, which is also a repeating decimal, 0.6 repeating. It includes other rational numbers like 0.25, which is 1/4, which is what we call a terminating decimal. It includes nice whole numbers like 5 or 0. 0 is a whole number. Or -6, which is a negative whole number, but that's actually, whole numbers usually start, well, they do start at 0 and count up. 0, 1, 2, 3, ... When we include the negative and positive whole numbers, as well as, of course, 0, because 0 is a whole number. Natural numbers are the whole numbers excluding 0. That's a lot. But the integers are whole numbers and they're negatives. Real numbers are like just everything. The decimals, the fractions, rational, and irrational. What's an irrational number? Well, pi is an irrational number. Radical 2, root 2 over 2, root 3 over 2, root 3 over 3. Those are irrational numbers. They are non-repeating. 2/3, 0.666 repeating is a repeating. They're non-repeating, non-terminating. 0.25 is a terminating decimal. Decimals. So they go on and on forever. They don't repeat. They don't terminate. Those are irrational numbers. So the real numbers include all of that. Integers are a select subset of that. Like I said, they include numbers like -2, -1, 0, 1, 2, ... in both directions, ellipses both ways. So what does this do for us? That means that you could fill in 0. If I had 2 pi over 2 0 times, then I'm just excluding pi over 2 in that moment. Plug in a 1. You're excluding that asymptote now too. Plug in a 2, the next one. Plug in a 3, the next one, because you'll combine and you'll get the next asymptote. And then we could write plus, because n will include negatives. So we could also go off in the other direction. And that little statement, mostly with words, we usually won't write it like this, but that little statement basically describes that x can be anything except these spots. And remember, here is my first asymptote, and here is the space between two asymptotes, vertical asymptotes, which is actually 2/4 or half of the period. That's the domain. From left to right, we always describe it. And sorry it's so crazy over there, squashed. What about the range? Range is actually a lot easier. I feel like range was a little bit more of a challenge for people back in Algebra 2. It was like weird because everyone wants to kind of look at it going downward like this. So if you need to turn your paper like this and just keep doing left to right, then go ahead and do that, okay? But range just goes from the bottom to the top. It's describing the y values, the possible outcomes or results that we would get from this equation, output of the equation. So in this case, these down arrows imply that my graph is going down forever. That's a negative infinity. So we start all the way down at negative infinity, work our way up. The highest we can get to without any interruption is -1, and that's included. This is interval notation. I'm using a bracket. Union, picking up where? I'm making a big jump, big gap. Really, what's a gap? I mean, there's an infinite number of numbers between any two numbers, so how big is it? I don't know. 1 until up and away, infinity. Parentheses on the infinities because you don't ever actually get to them. Brackets on the 1 and the -1 because we do reach those points. We can actually touch them. Okay? And this little union, it's sort of like uniting or bringing together these two intervals that we are using to describe our range. Okay? So that for you right there was, this is not the marker I wanted. Ooh, I don't think I've used this peach color, so we can use this now. So the domain, in this case, we used words, we wrote it out. Make notes for yourself, okay? I know the details I said out loud to you. You don't. Write them down. So that first number, it's not always pi over 2. That was the first asymptote in my graph cycle. I just added an extra cycle here. Plus, and then that number, 2 pi over 2, was half of the period, or it was 2/4. You'll have that information on your paper because you'll have graphed it, of course. n such that n is an integer, or given that n is an integer, that x can be any real number. Write these things down. And there's the range. One other thing, I'm just going to give you some symbols for real numbers. So real numbers, as a set notation, we have a symbol. So we don't have to write the phrase real numbers because we use it a lot in math. So we have a symbol. That's the real number symbol. So next time you can use that. And then for integers, it is a z with an extra line like that. Okay, so the integers and the real numbers, we have these symbols. So be ready for surprise quiz. Okay, hope that this was helpful. I hope that this helps jog your memory, because we're going to be doing graphing like crazy before we get ready for, again, limits. I know you probably heard me say it 1,000 times. I'm sorry. And if you can vibe with this, you get it, thumbs up. Not vibing with it, thumbs down. And I will hopefully see you in the guided example video after this.